Hello viewers, Alan here. Welcome to my workshop. So after a pleasant holiday break over Easter, I'm back onto the Lynx15. I think I mentioned at the start of this series that the drawings were actually prepared by another YouTuber, and his channel is Greg's Machine Shop, and I've put a link in the description to that. It turns out Greg's following my project with some interest, as it's helping to test out his design, which I gather is actually fairly new. And he's actually generously donated some of the buyout parts for the project. So I mean the bearings, the camshaft pulleys and the belt. So that's very much appreciated. Just a comment on the drawings, by the way. So far I've found them to be very clearly laid out and easy to follow. So really I'm quite enjoying this project. So I better get back onto it, hadn't I? And I'm going to start with the crankshaft. So I've roughed out the crankshaft. This diameter here is nominally or is specified to be 14, but I will be making the mating piece to go on it. So I aim to be close to 14, but it's not actually critical. But I'm at 14.009, so that's pretty close. So that one's finished. This one is to be 12, and 12 up close to the shoulder, because that's where the bearing will fit. So I'm sitting on 12.2 there, give myself a margin to clean up, 0.2 to come off. This one's got to be 10, and the 10 is important here. This is where the bearing will sit. That's currently sitting on 10.2 as well, or with a 0.2 margin. And with this one I'll be looking for 10.015 to 10.02. This last bit is nominally 8mm, but I don't really know what the tolerance is. There's no bearing on that. We're sitting on 8.2 again, so I'll clean that up to 8. But as long as I can get the thread on there, I think that's what we're looking for. One thing I noticed though, this 8mm, this section of the shaft, has a measurable variance. We've got 8.219 there, and 8.192 there, so a bit over 0.015, 0.017 or something, perhaps almost 0.02. So what's that, a thousandth or something from there to there. I might have a play with doing better than that, but for the moment it doesn't matter. I'll make sure I'm 8 here, and this bit here is going to have a thread cut on it anyway, so we're going to be close enough. So I think I'll start by setting this to 8, and we'll go in 2 passes. I'll take 8.1 I think to begin with. I let it cool down overnight, and you might have noticed then that it's lost the grip there, so I need to tighten this up slightly. Now we'll check, see what we were shooting for. I was shooting for 8.1 there. So let's see what we actually got, so we can make whatever micro adjustment might be needed. 8.126, that's quite a long way off. Okay. Alright, I think I'll do this pass at 8.05. So I've got another crack at my final sizing. So that pass was set for 8.05. I've got 8.04 at that end. And 8.056 at that end. So I think now I'll just go for 8 and we'll get what we get. So we're at finished length, and hopefully we're on 8. .002. Well, I'll take that. So we move on to this bit now. This one's got to be 10, particularly at this end. So that pass was set for 10.1. and we're on 10.105. So I think I'm going to go with this pass set to 10.02. Let's see what it actually gave me. Yes, 10.022. So I think that's slightly large. I was shooting for something in the range 10.015 to 10.02. Just checking on my fits here. This dowel pin measures at 10.009 and it's a pretty easy sliding fit in that bore. So I think this bearing bore must be on the high end of the tolerance. So with that said, I think I'm going to leave this at it must have cooled down slightly, leave this at 10.019. I think that's going to give me a good fit, so we'll call this one done. I will need to deal with a corner burr, a slight chamfer on there. Right, so this guy's got to be 12. Right, so that's my 12mm bearing. This is something I machined up a while back as a 10mm size guide, 12mm size guide, and that is that's pretty much what I'm looking for. You see that went on, but it's quite tight. It's not going to slip on the inner race isn't going to slip on that. So this is the diameter I'm shooting for here, or maybe slightly tighter, not much. So this mic's at exactly 12. This is what I made it to be. So that's why I said I was aiming for about 12.005, maybe 12.01 max. But 12.005 really is the target. So that was set for 12.1, and we got up here where the bearing fit counts. We've got 12.106. So I reckon I can just go straight for 12 now, and I should finish up at about 12.05, 12.06, which is exactly where I want to be. Alright, time to get my homework marked. What did I get? Hopefully 12.005 would be really nice. Oh, 12.01. Well, that's bigger than I actually wanted, but not by a huge amount. But I don't quite get what happened there. I'm going to try going in set on dead on 12 again. The bearing will sit here, so it gives me a chance to run on this piece here, which the bearing just has to pass over. So it gives me a chance to test the fit. So let's do that. That's a pretty good fit. I think that'll do, if we can get that where the bearing actually runs. So what did we finish up with for this 12mm journal? Not sure whether journal's the right word to use, but anyway, we're looking for 12mm. 12.003. I think the bearing's going to be very happy with that. Ooh. And that's just getting tighter. Oh, I can't get it off now. Oh God. Shouldn't have pushed it on there, can't get it off. Oh, we can stay there for a moment. Because I think this one's happy as well, isn't it? I've forgotten now whether I checked this one or didn't. So I just tried the 10mm bearing on its seat and it just felt too tight to me. I mean, it would easily press on, but that's not what I want. So I just touched it as lightly as I could with the cutter again. 1002 has dropped to 10016, and when I try the bearing on that, it feels now exactly what I want. It will push on, but you've got to push, so that's good. So that's both the bearing fits right, so now I've got to turn my attention to threading this section. Right, getting set up to cut this 5/16 24 TPI thread now. You can probably pick up that I've already done a scratch pass. This weird looking setup is exactly that, a very weird setup. But none of my proper holders would allow the insert to get to the end of the bar. So this is something I pinched off my tool sharpening jig. Anyway, I think it will hold this well enough. I hope it will. So I'll take light cuts though. So starting off at 7.95, I'll do my first cut at 7.4 and get lighter from there. And fingers crossed. Well, that seemed to be cutting right, didn't it? Right, well this could be the last pass, we'll see. I'm doing it at 6.7, which is the minor diameter for this thread. We'll see what happens. Yeah, I think that's pretty close. I'm going to run the die up for the rest of it. Right, well that's cleaned up alright, and that's on there with a pretty good fit. But there is one more feature to do here. Design calls for a groove, a 0.7mm groove about there somewhere. Drawing doesn't say what it's for. I assume it's for some sort of a circlip. Well, at least my weird thread cutting lash up worked, so I'm happy about that. And I think I will put a better chamfer on the end of the thread. I think that'll be a bit better. So one thing I found out with bearings and bearing tolerances, they're certainly not all created equal. This bar is a ground bar and it marks at exactly 10.000 millimeters. This is an NSK bearing and it's a firm, very firm push fit onto that 10 millimeters. In fact, it's exactly the fit that I'm looking for my job. This bearing here is unbranded, I assume it's Chinese, and you can see the bore is a lot looser. In fact, this bore marks out to about 10.015, and it's the bearing I was actually using for checking my dimension here. So I'm going to have to revisit that and reduce the diameter to suit the bearing that I actually want to use. Okay, before parting this thing off, I thought I'd do a final check on lengths. So this is the crankcase front and becomes the bearing housing. So the rear bearing goes in the back there, and front bearing. The drawing calls for the distance between that face and that face to be 60, and the crankshaft is set to match that face to that face should also be 60. Now I've checked my bearing housing carefully, and instead of 60 it's actually 59.94. So that means I really need to adjust the final length of the crankshaft. The other thing is that the 60 is on the making this 60 to match that is on the assumption that the depth of the two bearing pockets adds up to 14 millimeters, 6 and an 8. Well, mine add up to 14.006, which means the bearings will actually sit 0.006 closer together than specified. So with the target length established, I find that I need to actually shorten the distance from here to here by 0.05, and so I'm going to set the cutter here, just touch it lightly to establish a new reference mark, and then come back and cut this face to 59.945. Right, so let's set a new reference on this shoulder. Set Z0 at that, and we'll come this way, 59.935. And that should be that. Okay, so now I'm going to part this off to leave a 9mm piece here. That party company ahead of schedule. Okay, so that's finished that part of the crankshaft. So I've done a test assembly of the crankshaft into the crankcase front, which is the bearing housing, and you can see at the bottom there the lower pulley for the tooth belt. Now I wanted to do two things with this test fit. The first was to see where that pulley sat in relation to the opening, and I think what it's showing me is that the opening is wide enough, but the pulley needs to be not pushed right back to the shoulder on the crankshaft. So I've got a couple of choices. I can make this opening deeper here, or put a shim behind between the pulley and the crankshaft, and I think that's what I'll do, because I think the opening is actually wide enough. Anyway, so I'll take a measurement in a minute to see how thick that shim needs to be. The other thing I wanted to get from this test fit was to make sure the crankshaft length was correct. So the way this is intended to work, if a propeller is put on this crankshaft, the back face of the propeller boss would fetch up against the shoulder on the front end of the crankshaft. This is just a bit of scrap 8mm bore 10 diameter, which is a stand-in for the propeller boss. So what's interesting to me now is to try to see whether there's actually a clearance between the back face of this bit and the front face of the bearing. In other words, that the end of the crankshaft is holding this away from the front face of the bearing. And that's important because it will mean it will stop the two bearing centres from being squeezed together when a propeller or whatever is put on tight. So let's have a look here. The thinnest feeler gauge I've got is 1.5 thou, which may or may not show up here. I might be able to just catch it. Anyway, it's the thinnest one I've got. Hopefully you'll be able to see that that's actually just gone in. So the clearance that I do have end float clearance there, probably somewhere between 1 and 1.5, closer to 1.5 than 1 probably, but that's pretty much ideal. So very happy with that. I've got the crankshaft the right length, and I'll use the feeler gauge down the hole there to work out what thickness of shim I need to bring the pulley forwards. That's about 2mm. So that tells me how much space I've got to play with to bring the pulley forwards. So with the pulley slid forwards to the correct position, I can see that I have to bring it forwards the 2mm plus the thickness of one of these rims to get it correctly spaced. And also it's a confirmation that the hole is at the moment only just wide enough, so we'll do a final clean around and then it should be just good. So knocking the crankshaft back out of the bearings, you'll see that all my fiddling around with the bearing fits paid off, because I wanted the bearings to be a firmer fit in the housing than the shaft is in the centres. But I wanted this to be firm anyway, so it was a bit of a balancing act. But anyway, as you'll see, it takes just the right amount, from my perspective, effort to knock the shaft out. That's clear now of both bearings, and the only thing left to do is push the shaft through the pulley. And I've got a good fit on that pulley as well, as you can see. I can just push that through. there we go. So I know I spend a lot of time fiddling around with those fits and whatever, but anyway, I'm very happy with the end result. So I've moved on to making the web for the crankshaft now, and the piece of material that I'm using here, well actually it was a tool that my late father-in-law made. He was a refrigeration mechanic, and this is a flaring tool for copper pipe. So there's a series of different diameters with a chamfer on the front, and the idea was to belt it into the pipe to form the flare. Anyway, it seems like pretty reasonable steel, and I've run the cutter over it, and I was aiming for 50. I guess that's pretty close. So I'll face the end off now. Take a 0.1 cut to start with and see how deep some of these dings are. Probably, let's take 0.2 actually. I don't think 0.1 will do it. Might finish up taking 0.5 millimetre. Alright, the web has to be 8.5 millimetres thick and a tight fit obviously on this diameter here. The drawing, the suggestion is to use Loctite, but I think I'm going to shoot for a very tight press fit. So this measures at 14.01, so I'm going to shoot for a hole which is 13.98, and that should give us a pretty tight fit. Definitely a press fit. And I'll start off by banging a 13mm drill in. I've just put a centre in there, but I'm going to use the 13mm drill to kick things off, and then bring a boring bar into play. As I said, the web is at 8.5 thick, but I think I'll go in at least 20, and then that leaves the possibility of if I mess it up, I can part another one off. I usually drill pilot holes for this sort of thing, but I thought I'd just have a go at going in one pass here. So I think that will do for that. I'll bring the boring bar into play. Okay, so I'm working on boring this to finish size now. I want it to be 13.98, so that this thing, which is 14.01, should be a press fit into that. I'm currently sitting on 13.78, and so I'm going to go in two passes. I'll go at 13.88, and then I'll make a final adjustment before I do the last pass. Sounds like a good plan, doesn't it? We'll see. Alright, so let's see how close we got to 13.88. I'm pretty happy with that. So we go in now at for the final pass, 13.98. Well, I'm going to call that close enough. And I've got a tiny chamfer, or a very small chamfer on the corner of that. So, yeah, that's going to be tight, which is of course what we're looking for. Yeah, it's not even thinking about starting with that sort of pressure. So I had another go at just starting it in hull with a bit more determinedly. It will actually start if you give it a good shove. So I think that'll press on all right. So that's the shape of the piece I'm trying to make, and I think I'll just basically take a slice off this bit that I've been working on and do the rest of the operation with it stuck onto the crankshaft and over on the mill. That parting tool did a pretty good job too. Alright, okay, another little bit of machining for this crankshaft. Actually it's an assembly piece, a fixture or something, fitting I suppose, I don't know, to assist with assembly. The web has to be pressed on, leaving 1 millimetre of this diameter exposed, so that creates 1 millimetre of clearance between the back of the web and the inside of the bearing housing. So I've got a 1 millimetre slice off the end of this piece, which I've set up to be the right diameter, the right bore, and I think I'll use the power feed this time. I don't think I've ever done parting off with the power feed. I wouldn't have dreamt about doing that on my old lathe, but I think for this one, well, let's give it a try. Well, it's fairly painless, and I think the washer finished up a reasonable approximation for 1 millimetre. I don't think 0.03 is going to make any difference. Alright, so I've been dithering around trying to decide how to proceed, and I was thinking about making a temporary arbor to mount this on to do the machining, and I thought, well, I don't actually really need to do that. I should be able to do it directly on here. Use this sort of setup with the R40 collet chuck. And yeah, anyway, so I need to press against this face here, and that will sit on the top of the collet. And there's my 1 millimetre spacer. Which will fall off the back afterwards. And then put this on this way around, and this is 8.5mm thick, and the amount sticking out here is 8, so I'll be able to do a clean up pass on the this other face here. Alright, so we can put that on there. I don't know if there's any point putting Loctite on it because I expect it to be pretty tight, but I suppose I can put some on. Can't see how it would do any harm. I think you see there's just a few dots around there. Alright, well, let's see how we go. We've got a problem here. Right, well, that turned into a disaster, a complete disaster. Several things went wrong. The first is that I didn't wake up to the fact that the 1 millimetre thick washer which I have here wasn't enough to hold all this lot above that face. So that was the first problem. And in panic mode, while the 648 was doing its thing, I grabbed another washer to put in there and make up the space. But as I say, it all went wrong under here somewhere, and that yeah, I don't know now how much. I don't know whether this is, I don't know whether this is retrievable at this stage. It quite likely isn't. And in the process, also, I broke the part of the collet ER40 nut. So I learned a lesson there. Don't use these things as press accessories, they're just not meant for it. I'm sure it would have been fine if I hadn't got in a tangle all these other stuff and started putting a lot more pressure on than I expected to do. But anyway, so I'm going to put it in the lathe and see if I can clean this mess out here and then see what we've got. But I don't think the shaft has gone into this far enough, and that 648 will have gone off by now. So it's possible I can use heat. Anyway, as I say, a disaster. So I'm going to disappear into a huddle with myself and see whether I can retrieve anything from this or whether I'll start all over again. Not my best hour. Yeah, well, that is a complete disaster. The section here is damaged, and that didn't go on far enough. So we've got to start all over again. And yeah, not happy about that because there's quite a few hours getting to that stage. Such is life. Well, that didn't go the way I'd planned or hoped, did it? But life's like that sometimes, I guess. I did actually even put a lot of heat on this thing trying to separate them, but the Loctite 638 wasn't even going to let go with that. So I do have to remake both of those parts, but there's no point filming that, of course, so I'll do that off camera, and when we resume with the next episode, it'll be to pick up from where I've left off. Yeah. Anyway, thanks for watching, and perhaps there was something in there that was enjoyable, apart from me messing up big time. Anyway, cheers, and hope to see you on the next one.